Okay, guys. Okay, we will discuss some questions over here. So let's get into it. So now, number one, okay, the value of third ionization energy is given. So how do I represent this? Okay, so ionization energy, third ionization energy means you are removing the third electron, okay, from something that has been two electrons has been removed from it. So if you have gallium, okay, if two electrons have been removed, so gallium 2 plus, and you need to remove one electron to give you gallium 3 plus, and then you remove that. And always remember it must be in gaseous form. And since it is removing electron, it must be endothermic reaction. Okay, you are giving input of energy. So delta H, okay, in this case must be positive. So if you look at the answer over there, okay, the one that will match the answer is going to be B. So B is going to be the correct answer. Yeah. So you see here, okay, and it's positive. Okay. Next question. Okay. So this one all can be cancelled. Okay. Now, so number two, gaseous particle X and Y have proton number N and N plus 1 respectively. Yeah. So X has a charge of plus 1, Y is isoelectronic with X. So what is it means by isoelectronic? Okay, it means that they have the same the same electron, yeah, same number of electron. Okay, Y is the same number of electron as X. So here, okay, they say they X and Y. I'll just put X and Y. Okay, they have the proton number, so I'll just put N plus 1. And X has a charge of plus 1. Okay, so charge plus 1. And then Y is isoelectronic. So if I just want to write down what is going to be my proton number is N over here. The proton number here is going to be N plus 1. Okay. But how about the electron, number of electrons? Since, okay, it's going to be positive 1 charge, okay, the number of electron over there is going to be normally supposed to be same as proton, okay, but it's going to be N. Okay, I remove 1 electron, it's positive 1 charge, so N minus 1. Now here, okay, this electron, since they mentioned that it is isoelectronic with X, okay, but now, okay, when you look at it, it's going to be, if it is neutral, if Y is neutral, then they're supposed to follow the same as proton, N plus 1. Okay, but I need to make sure that the electron, number of electron is going to be N minus 1. Okay, so how do I get N minus 1? It means first you remove 1 electron. Okay, so you get N. So if you remove 1 electron, so it's going to be plus 1. So if you remove another electron, okay, then it's going to be N minus 1. Okay, so is N plus 1, I remove 1 electron, I remove another 1 electron, I will get N minus 1. Okay, it means this is going to become 2 plus. Okay, using this, okay, now I have identified all the important stuff. Okay, using this, so I just can write down this as N minus 1, isoelectronic. So now use which one is correct. So X has smaller ionic radius than Y. Okay, you see, it's going to be something like group 1, group 2. Okay, so we know that when you go across periodic table, the size is getting smaller. Okay, so if you look at the X has smaller ionic radius, okay, not really. Okay, Y has a smaller ionic radius, so this is wrong. Okay, X has more proton than Y. You see here. Okay, Y, yeah, indeed has more, N plus 1, more than N over here. So this one is wrong. And then X requires less energy than Y. Okay, when another electron is removed from each particle, do remember they have already removed 1 electron here, 2 electrons here. So if you want to remove 1 more electron from each over here, it is going to be more difficult to remove from here. Why? Because the nuclear attraction is stronger. Yeah, you can see from the size itself. Okay, so to remove from Y is going to be you require more energy. So X is going to be less energy, which is the statement is correct. Okay, but we check for D. Now X has a stronger force of attraction to its outermost electrons than Y. Not really. Okay, here, okay, Y will have a stronger attraction force towards the outermost electron. You can see from the diagram over there. Okay, so therefore, okay, the answer is going to be C. Now next, okay, number 3. Strontium metal can be extracted from strontium oxide by reduction of this. Okay, so if I want to find out maximum mass of strontium metal that can be produced from the reduction of 200 gram strontium oxide from this reaction. So first, okay, find the number of moles, okay, of strontium oxide. So 200, okay, 200 divided by, okay, strontium oxide. Okay, if you look at the periodic table, hold on, I'll just check, okay, from the data booklet. Okay. Now, if you look at the data booklet, okay, so strontium, okay, strontium will have, give me a moment, 87.6, okay, so 87.6, and then oxygen is 16, okay, so you are going to calculate this, okay, so let me quickly calculate this for you. So here 200, okay, 200 divided by 87.6 plus 16 and close bracket. Okay, you are going to get 1.93. Yeah. So if you have 1.93, so let's see, 1.93. I'll just put it over here. 1.93. Okay, 1.93 moles. Yeah. So this is going to represent 6 over here. Okay. I am looking for, okay, the strontium metal, which is going to be 3 moles. Okay, so if this is 1.93 over here, this is going to be the ratio. Yeah, you can see 6 to become 3, it means half of it. So 1.93, I need to divide by 2. Okay, so when I divide by 2, okay, sorry, 1.93, okay, I divide by 2, I will get 0.965. Okay, so this is 0.965. Do remember their number of moles. Okay, I need to change it back, okay, to mass. Okay, so how do you get it? Number of moles is mass over AR. Okay, mass is going to be number of moles times the AR. So number of moles is going to be 0.965. The AR just now I saw is 87.6. Okay, so if I times that, okay, so answer I times with 87.6. And that will give me the answer, which is going to be 84.534. Okay, so this one, okay, is going to be the answer. Okay, so this is going to be, okay, I think here we get 84.534 because I used the 1.93 directly over there. But if you use the full value, yeah, you will get 84.6 gram. Okay, that is number 3. So let's actually move forward, okay, to the next one. Okay, so I'll just leave the calculator over here. Maybe we will still use it. Okay, so 12.5 cm cube, okay, potassium hydroxide. Okay, then you are reacting with the HCl. Okay, so I'll just write down KOH, okay, plus HCl. They will give you KCl plus H2O. So I just need to find out what is the number of moles, okay, of potassium hydroxide. Okay, so number of moles of potassium hydroxide, I can just quickly calculate over here, which is going to be 12.5, okay, times 0.05. Okay, then you divide by 1000. Okay, that's going to be your number of moles. Okay, I just put 65. And then we look for the number of moles of HCl. Okay, so 37.5 times 0.1. Okay, and then I divide by 1000. And that's going to be 0.0375. So what we need to do, okay, we know that, okay, if we balance the equation, 1 mole react with 1 mole. So we know that the one that is in excess is this one, okay, the number is bigger, yeah. So what we need to do is just to minus, yeah, so 0.0375, you minus with 0.00065, okay, and then, hold on. So I'll take the answer minus with 0.000, and you will get, okay, so this is the excess, yeah, so you will get 0.03 0.3125 moles, yeah, moles. And I'm looking for concentration. So do remember, one of the common mistake is not adding the volume for both. Yeah, since they are both solutions, okay, you need to add them. So it's going to give you 12.5 plus 37.5 is going to be 50, yeah, 50 cm cube. So I need to change this 50 cm cube, okay, 50 cm cube divided by 1000, yeah, so into dm cube. Okay, so when I do that, I think 1 over 20. So this one is 1 over 20. Okay, so this one will be, if I want to calculate, it's going to be, I just need to times by 20. So I just answer times 20. This is going to be my answer. Yeah, so you will get 0.0625. Okay, mole per dm cube. Okay, that's the answer. Okay, I think for now we can close this. Okay. So if you move on, yeah, for question number 5, okay, iron as a high melting point. Iron is metal, yeah. So what is the reason? So this is very interesting. Okay, when it comes to metal, you need to know it's actually the bond between iron ion, yeah, iron ion and delocalized electron. Yeah, so this one is going to be B. The other answers are wrong. Now, which of the following species has a square planar structure? Now, square planar structure is going to be something like this, okay? 4 bonding pair and then 2 lone pair. So 2 lone pair over there. So we are looking for 4 bonding pair and 2 lone pair, okay? You know the AlCl3, okay? If I want to draw for AlCl3, it will look like something like this. Let's put Al. Okay, the electron, 1 pair of electron will be donated over there. So it will look like this. Okay, and then if you look at the aluminum is having 4 bonding pair, yeah, 4 bonding pair, and you don't have that 4 bonding pair, 2 lone pair. Okay, and therefore this is not, yeah, it will be something like a 3D structure related to like tetrahedra and so on. Okay, for this one, okay, sulfur is going to be group 16, 6 valence electron, and it's going to be sharing the electron with 6 atoms of F. Yeah, so they will follow this structure. Okay, they will have this and then up and down. Okay, so this one is known as octahedral. Okay, octahedral. So we are looking for square planar. Yeah, that is not the answer as well. Okay, so BrF4, Br is going to be group 17, 7 valence electron. So 1 electron coming in. So 8 valence electron. So you have 4. Okay, so Br, okay, so it will share, okay, 1 electron here, okay, to the F. Okay, you have something like this. Okay, and they have another 4 more electrons. So what I can do, maybe I can do it much more better if I just represent this over here. So if this is Br, so you have F, F, F. The remaining 4 electrons will be arranged in pair up and down. So you can see 4 bonding pair and 2 lone pair. Therefore, the answer is going to be D. Okay, so this one will not be the answer. Okay, so this one will look like, okay, boron is group 5, so 1, so 6 electrons. Okay, so it will have 4 bonding pair and then 1 lone pair. Okay, it doesn't match with what we have. Yeah, so we are looking for D. Now, next question, okay, number 7. Under which condition can a gas most likely behave ideally? So if you want them to behave ideally, we don't want them to stay close to each other. They must be further away from each other. Okay, so how do you make them to go further away? Of course, the temperature must be high. Yeah, temperature must be high. They must have enough energy. So this one is wrong. Okay, and then the pressure cannot be high pressure. Okay, if high pressure, they are going to become closer. I want them to be far away from each other. Okay, so it must be low pressure. So therefore, the answer is going to be C. Okay, number 8. Which pair of enthalpy changes will always share the same sign? Yeah, this is very important. Okay, you need to remember certain things. Yeah, so atomization is always going to be breaking of the bond. So atomization is always going to be positive. Okay, neutralization and combustion is always negative. So A is wrong. Okay, atomization is positive. Okay, ionization energy is going to be breaking the bond. Yeah, you are removing the electron. So of course it's positive. So therefore you get the answer already. Combustion is always negative. Okay, formation. Do remember for formation. Okay, we the sign. Okay, for the formation is always going to be either positive or negative. It can be positive or negative. Okay, it's not reflected over here. Let me check again. Let me share the screen again. Let's continue. Yeah. So if you look over here, okay, always remember, okay, enthalpy change of formation can be positive or negative. Okay, therefore cannot be that. Solution, yeah, solution can be also positive and negative. Do remember, okay, we have already learned about this. If your enthalpy change of solution is going to be negative, yeah, they are going to be soluble. Yeah, if it is a small positive, they are soluble. Yeah, big a large positive, then they are insoluble, and so on. So enthalpy change of hydration, do remember enthalpy change of hydration is always negative. Yeah, it's going to be formation of bond. Yeah, so it's going to be always negative. Okay, therefore, okay, the best answer is going to be B. Yeah. Now for number 9, okay, so you have all this data. So whenever you have this kind of situation, formation, okay, the best way to do this calculation is by using this method. Okay, to form. Yeah, so you see N2H4 to form N2H4. So you put the arrow to form. Okay, so this is going to be 2 times 50.6. Why? 2 moles over there. To form N2O4, okay, is 9.2. So 1 mole. So it's okay. Now do remember, I do not need energy to form nitrogen. So 0. Yeah, 0. Any elements you no need to form. Yeah, so 0. For water, okay, there is no enthalpy change of formation for water. Yeah, but they have given the combustion. So first thing what you do, you write down the equation for combustion. H2, okay, plus O2 to give you water when they combust. Okay, before I balance, I need to remember back the definition. Definition is 1 mole of substance combusted completely, okay, with excess oxygen, okay, to give the product or something. So if I want to maintain 1 over here, so how to do that? So this one I just put half. Okay, no need to go and times by 2 because I want to maintain, okay, the definition over there. Okay, so if I look at it, this is negative 241.8. Now this one can be also represented, okay, as enthalpy change of formation. What is the definition of formation? 1 mole of substance is being formed, okay, from its element. You see these are all elements, okay. They are being formed from the elements under standard conditions. So therefore, okay, your enthalpy change of combustion is also your enthalpy change of formation of water. Okay, so therefore here to form this water is going to be 4 times negative 241.8. Now once you do that, okay, so we just looking for this x, okay, so you should know clockwise equals to anti-clockwise. Okay, so if you write down the equation, okay, this one, okay, plus 9.2 plus x. Okay, we know all these are going to be clockwise. This one is anti-clockwise. Okay, so it equals to 0 plus 4 times negative 241.8. Okay, you calculate, you find, you will get the x, okay, to become negative 1077.6. Okay, please calculate. You will get the answer. Okay, that's going to be A. Now, next question, number 10. Now, in order to do this question, okay, it's quite simple actually. Yeah. So this is going to be iron 2. Okay, the trick to do this is to use this iron 2. Iron 2 is Fe2 plus. Okay, therefore I know TiO3 must be 2 minus. Okay, so I can calculate what is the oxidation number of titanium. So X, okay, and then plus 3 times negative 2, negative 6, okay, equals to negative 2. So I will get X equals to negative 2 plus 6, okay, I'll get plus 4. Now, for titanium oxide, yeah, so X, okay, minus 2 times negative 2, yeah, so plus 2 times negative 2 is negative 4 equals to 0. So X equals to plus 4. So you can see from plus 4 changing into plus 4, okay. So there is no change in oxidation number. So therefore, the answer is going to be D. Next, which factor will change the value of equilibrium constant? This one, very simple question. Yeah, only temperature changes the equilibrium constant. Yeah, very easy question. Now, next. Now, for the next question, do remember, okay, if I'm using Kc, I need to ignore the solid. Okay, remove the solid. So Kc is going to be 1 times 10 to the power of 5. Okay, so you just need to put the expression, okay, Cu2 plus divided by, okay, Ag plus, okay, to the power of 2, okay, equals to 1 times 10 to the power of 5, okay. So now you have the value 0.1, okay, so you just need to put 0.1, okay, divided by Ag plus to the power of 2, okay, 1 times 10 to the power of 5. You just need to find what is going to be Ag plus, okay. So this one, okay, if I want to put it over there, it's going to be 0.1 divided by 1 times 10 to the power of 5, okay. So you will get 1 times 10 negative 1, okay, then minus 5, 1 times 10 negative 6, okay. So Ag plus, okay, is going to be square root. You will get 1 times 10 negative 3, okay. So this is going to be the number of moles, okay. Of course, I need to find for in form of gram, okay. So you need for silver, okay, silver ion, okay. So you have to refer to your periodic table. Silver is 107.9. So 107.9, you just need to times with the number of moles, okay. So you will get, okay, 1, 2, 3. So you'll get 0.1079, yeah, which is going to be this. Okay, you can calculate. Now, next. The next is going to be, this is going to be a Maxwell-Boltzmann's curve, okay. So you have this distribution, and when we say higher temperature, this one you need to know, okay. If let's say, for example, if I have a higher temperature, it will go like this, the peak will become shorter, yeah, and then it will move to the right. So if this one, another one, it will be something like this, okay. So something like this is lower. So now they say which one correctly describe the effect of decrease in temperature. So which one that they are referring now, they are referring, this is higher temperature, this is going to be lower temperature. So they are referring to this graph, yeah, the one that is in the blue color over here. So what can I say for that? Yeah, I can simply say the peak will be higher. Yeah, peak will be higher, so definitely cannot be lower. And then you can see as I go over here, okay, the number of molecules that has more, okay, than activation energy is less compared to the earlier one. The earlier one will have more. Okay, so fewer molecules will have activation energy that is going to be greater than activation energy. Sorry, energy more than activation energy. Okay, so therefore the answer is going to be A. Now 14. Which oxide is insoluble in water? This one very important also. Okay, basic oxide, yeah, so they will be soluble in water. Okay, this one, they are soluble to give you sulfurous acid. Okay, they are soluble to give you phosphoric acid. Okay, but this one, okay, they are insoluble. Okay, insoluble in water. Okay, so this one you need to know. Okay, B. Now 15. Okay, the following graph, yeah, this one I think we will skip, okay, because there is going to be a mistake and an error over here for the diagram. Okay, so let's move on to question number 16. Now, sulfur is an element in third period. Okay, which one is true for sulfur? Now, sulfur is the only element in this period which forms two acidic oxide. Not really. Okay, phosphorus, okay, can form P4O10, and they can also form P4O6. Okay, therefore, okay, they are not the only one. Yeah, they are not the only one. Sulfur can form SO2 and SO3. Okay, sulfur has the highest first ionization energy of the element in the period. So you need to remember, okay, if you have aluminium, silicon, phosphorus, sulfur, you have chlorine and argon after that. Okay, we know that, okay, as you go across the periodic table, size will become smaller and smaller. Okay, so if you are looking for ionization energy, of course, the ionization energy of chlorine and so on, okay, will be greater than sulfur. Okay, so I don't agree, okay, that this is going to be the highest. No. Now, sulfur is the only element in this period whose oxide reacts with water to form acidic solution. Wrong, yeah. So they this one, okay, sulfur, yes, they will give you acidic solution, but not only that. Silicon oxide, okay, when they react with sodium hydroxide, they can react with sodium hydroxide. They will give you NiSiO3, yeah, and water, okay. So they are going to give you this solution, yeah. So you have silicon oxide, Okay, you also have, okay, phosphorus, okay, P4O10 can also react to give you the phosphoric acid. Sulfur also will react, okay, and then this one also will react. So it means that this is not the only element. Yeah, they are not going to be the only element. Now, sulfur is the only element that can exist at room temperature. A simple molecule containing 8 atoms. Yes, correct. Sulfur is the only one that can exist in this form. Okay, phosphorus, on the other hand, can exist in P4. Cl can exist in form of Cl2. So this is additional knowledge. Okay, therefore D, okay, will be the answer. Now, number 17, okay, the following involves group 2 elements or their compounds. Okay, so we want which one will produce gas. Okay, always remember group 2 metals or group 1 metals, when they react with water, okay, they will give you barium hydroxide. Okay, you are going to get hydroxide and you are going to get hydrogen gas. Okay, so gas is produced. Okay, barium chloride and sulfuric acid. Okay, if you are not sure, okay, you can try barium, okay, sulfate, maybe barium sulfate. Okay, then maybe HCl. Okay, so do remember all of them are going to be in aqueous. Most likely this is also aqueous. So I don't think so. There will be gas that will be produced. For this, yes. Okay, calcium carbonate and excess hydrochloric acid. Yeah, this one really everyone should know. Carbonate reacting with acid, okay, they will give you calcium chloride, okay, they will give you carbon dioxide and water. Okay, so this one is very important. So you can see that carbon dioxide is given off. Yeah, this will be the answer over there. Magnesium sulfate and sodium hydroxide. If you're not sure, it's okay. You can guess magnesium what? Magnesium hydroxide, for example, maybe magnesium hydroxide. And then I have sodium sulfate, for example. Okay, I don't see any reason, any way where gas is going to be given. So here, which one will produce gas? Yeah, I can see only 2. Yeah, so the answer is going to be 2. Next, 18. So student conducted an experiment with sodium halide solution. Okay, the following are the results. The moment you see cream precipitate with silver nitrate, so you need to know silver, okay, silver chloride, silver bromide, and silver iodide. Must know white precipitate, cream, and then this is going to be yellow. Okay, so we are talking about AgBr. Yeah, so this one definitely has to do with Br. So sodium Br, yeah, sodium bromide. Okay, addition of concentrated ammonium solution. Yeah, if you have Br, okay, this AgBr, they will be dissolved. Okay, the precipitate will dissolve only with concentrated ammonia. So they dissolve, so it matches. Yeah, the still, okay, we know that is AgBr. Now, addition of concentrated sulfuric acid. Now, I am going to add NaBr. I'm going to react with H2SO4. So what I am going to get, okay, I am going to get Na, okay, SO4, okay, and then HBr, okay. So I will get something like this, okay, but do remember, okay, this one, this HBr, okay, they do not stay as it is, okay. The reason is this sulfuric acid is a very good oxidizing agent. The HBr will be further oxidized, yeah, by H2SO4. They will give you Br2, yeah, Br2 and a mixture of other products. You can actually check. Okay, so this one you are going to get Br2. So a brown solution is produced. The brown solution belongs to Br2. Okay, so therefore it's a confirmation, okay, that this is going to be a sodium bromide. Yeah, sodium bromide. Now, 19. The following 2 experiments are carried out, okay, with anhydrous potassium bromide. Okay, so observation X and Y are made at each of end of each experiment. So if you are using, I think this question is similar to question number 18. Yeah. So if you are using concentrated sulfuric acid, okay, when I add to potassium bromide, okay, so this is similar like when you are adding it to sodium bromide. Yeah, so I am going to get, okay, supposed to get, okay, K2SO4, okay, and HBr. But do remember, this is a strong oxidizing agent. They will oxidize HBr, okay, sorry, they will oxidize HBr, okay, where they are going to give you Br2, okay. So that's why they say that the halogen produced, okay, halogen that will be produced is Br2. So the Br2 is further reacted with potassium iodide. So Br2, when you react with Ki, so we know that Br2 is more reactive than iodide. So displacement reaction can happen. So you will have KBr plus I2. Now this I2 is the one, okay, if it is going to be in aqueous solution, okay, you are going to get, okay, a brown solution. Do remember, I2, when they are in solid form, they are black. Okay, when I2 in solution form, they are brown. When they are in gaseous form, they are purple. Okay, so there will be a brown solution. So brown solution, so cannot. Okay, let's look at the observation with Y. The potassium bromide is dissolved in dilute aqueous ammonia. This one we can wait first, okay? And this is added with aqueous silver nitrate. So silver nitrate, it means we are talking about AgBr. Okay, silver and bromide, yeah, AgBr. So AgBr, we already discussed just now, they will give you a cream precipitate. Now this AgBr, okay, when you dissolve them in dilute aqueous ammonia is not enough to dissolve this precipitate. Okay, unless we are using a concentrated ammonia. Okay, so the cream precipitate will stay. Okay, so we are going to be able to see that cream precipitate. So therefore, the answer is going to be. Okay. Now, which substance does not produce a poisonous gas, okay, when burned in limited amount of air? Okay, sulfur, limited amount of air, SO2, SO3, yeah, they are all poisonous. Okay, ethane, okay, limited amount, yeah, you will get carbon, you will get carbon monoxide, yeah, so definitely it will produce, okay. Nitrogen, yeah, nitrogen oxide, yeah, all these are going to be poisonous. Okay, but what hydrogen, when you burn them, okay, of course, there's only, you are going to get water. Okay, water is not going to be poisonous. Okay, so it's going to be, the answer is going to be D. Now, next, which compound is unsaturated? When you see the term unsaturated, it means that they must have double bond. No double bond, you cancel. Okay, very easy. Okay, how to do this question? Cancel C and D. There is no double bond. Okay, there is a double bond over here. There is a double bond over there. That is unsaturated. Now I want to find out acidic. The moment you see this, okay, carboxylic acid, they are acidic. Okay, A. Alcohol, they are neutral. Yeah, so there you do not need to worry about that. So the answer is going to be A. Number 22. So here you are going to have this compound, and then we are looking for how many chiral center. Chiral center means the carbon must have 4 different groups. Okay, automatically if you have the carbon here, 2 same group, hydrogen and hydrogen, cannot. Okay, so I will actually look for the one that has 4 different groups. Cannot. Okay, cannot. Okay, why cannot over here? Because, okay, you have double bond. Okay, if you have double bond, maximum groups will be 3 only. Yeah, I need 4. Okay, so next I will look over here. This is going to be one group, another group, and there will be hydrogen. So this is going to be one chiral center. If you look at this, okay, one group, another group, another group, another hydrogen. Okay, therefore this is going to be another chiral center. This one, 2 hydrogen, no. 2 hydrogen, no. Okay, but if you look over here, 1, 2, different. Okay, and then there will be another hydrogen. So therefore 3. So here, okay, how many chiral center? The answer should be 3. Thanks. Now, in this diagram, it shows the repeat unit of an addition polymer. Yeah, what is going to be the correct name? Okay, this one quite simple. Okay, this one break over here, you put the double bond over there. And then you need to name them, okay, according from the longest carbon chain. So you see the longest carbon chain from here to here. Okay, how many carbon that I have over here? So I have 2, 3, 4, 5, 6. So it means I'm looking for 6 hex. Okay, hex. Forget about the rest. Okay, pent, add, no. Okay, and then do remember this is going to be opposite. Okay, so it must be trans. Automatically you get this as the answer. No need to think a lot. Yeah, that will be the answer. Trans. Okay, next 24. So here I have put 1 in. I will just quickly draw put 1 in. Okay, put is 4. Okay, put 1 in and put 2 in. I'll just put over there. Put 2 in. They are going to be treated cold dilute acidified manganate. Now, if you have cold dilute condition, then you are going to get this diol. Okay, the double bond is broken, so you have OH. You will have OH. double bond is broken, you have OH here and you have OH here. Now, so they are making some statement. I need to find out, yeah, which one is correct and so on. So here, okay, they are looking into this primary alcohol, secondary alcohol, and so on. So I think better if we can just put H and then H. You can see that this alcohol, the carbon, is bonded to one R group. Okay, so this one is going to be primary. If you look at this carbon over here, okay, this is going to be hydrogen. So this is going to be bonded to one C, another C here. So therefore, okay, this is going to be a secondary alcohol. Okay, let's find out for this. Okay, so this is one carbon, another carbon. So there is one hydrogen. So this is going to be secondary. One carbon, another carbon. Okay, this is hydrogen. So this is going to be secondary. So you see, one diol contains two primary alcohol group. I don't see two primary alcohol group. Okay, that is wrong. One diol contains a primary and secondary alcohol group. Yes. Okay, so this one is correct. One diol contains two secondary alcohol group. Yes. Okay, this is also correct. Both alkenes exhibit cis and trans isomer. No, you see that this one, the carbon over here, has two same groups. Cannot exhibit cis and trans. So this one, no. Yeah, so the answer is going to be X and Y. So this is going to be my answer. Okay, next. So 25. Okay, so when this compound, okay, reacted with aqueous sodium hydroxide, okay, a substitution reaction that follows SN2. Yeah, so if you have SN2, yeah, so do remember, if I draw this, okay, C6H5, then C double bond O, and then you have CH2 and you have Cl. Okay, if I draw this and I can see that what kind of halogenal alkane is this, the carbon attached to the halogen is going to be attached to one R group. So this is going to be a primary halogenal alkane. Primary halogenal alkane, they will undergo SN2. So they will not form carbocation. Okay, so they will form intermediate. So the moment you see carbocation, automatically will not be the answer. Okay, so if you have this, all this will not be the answer. So it must be something like this. Okay, something like this. So let's actually look at what will be possible answer. Okay, we know that Cl will come here, then OH is the nucleophile. Okay, so the OH will be attached over there. So it's okay, both of them. Okay, but you have a look at the one that is, this is delta negative, correct? But this is delta negative, wrong. Okay, this is going to be supposed to be delta positive. This is delta negative and this is delta negative. Yes, correct. So this will be the answer. C will be the answer. Number 26. Now, only stereoisomerism should be considered when you answer this question. This is a very interesting question. If you have H over here, okay, H over here, if I erase this, okay, what will happen? You are going to get a double bond over here. You remove the Br, you remove the hydrogen. So if I draw this, I will have C2H5 attached to C, and then you have CH3, and then double bond, and then I have CH3. Now, if I remove this, and then if I'm looking at the left, okay, so if I remove this, this is hydrogen, this is hydrogen. These two will be gone, so you will get double bond over here. So if I put this carbon, okay, then I have CH3, and then there is hydrogen, double bond will come. So I will have CH3 here, and then this one is C2H5. Now, if I compare these two, okay, you can see C2H5CH3, C2H5CH3, CH and CH3. So both of them, they are actually the same. Yeah, this one and this one, they are the same. But they can, okay, they can exhibit cis and trans. It means they can have cis over here and they can have trans over there. Yeah, so you know how to draw. Okay, so these molecules have two. Okay, but the answer is not two. Yeah, so always remember there is another one. Okay, do remember this is going to be the carbon, and then there is 3 hydrogen over here. Okay, so the hydrogen here and the Br can go out, and you will have a double bond over here. So how do I draw that? Okay, it will be something like carbon. Okay, then I have C2H5. C2H5, double bond with this carbon, hydrogen and hydrogen. Okay, but the interesting part with this is they don't have cis and trans because the carbon is attached to the same groups. Okay, so there's only one specific. So now, how many of them? You have 1, 2, and 3. Yeah, so 3 different. Okay, that's all. Okay, for today. Yeah, later we will continue. Okay. For question number 27, they are asking us which alcohol will give you a yellow precipitate when warmed with alkaline aqueous iodine. Now, this one is going to be your triiodomethane reaction. Yeah. For triiodomethane reaction, if you have alcohol, okay, it means that they must have the OH group, they must have the H group, they must have CH3, and then can be any R group. Okay, so you need to have this criteria, okay, in order to give you the yellow precipitate. On the other hand, if you are using like any aldehyde or ketone, yeah, so you must have the CH3 there, and then you must have the R group, something like that. That's the difference, yeah. So here, okay, in order to get the triiodomethane reaction, yeah, so you need to have this. So we are looking for this. So from here itself, okay, I can eliminate some things, okay, but I will show you directly also. The carbon, okay, is attached to 2H group, and then OH, and then there is C, and then there is going to be CH3, and another CH3. You can see that, okay, they do not have CH3 directly attached to it. They don't have this structure. Okay, therefore D is not the answer. I will show you for C. Okay, for C, you can look at this carbon. This carbon has OH. It has 2 CH3s, and then followed by C2H5. Okay, so you see, it's okay, they have CH3OH, but they don't have the hydrogen. Okay, they don't have that hydrogen. Therefore, okay, we will not select that. Yeah, there is no hydrogen here. Yeah, so this is wrong. Now for A, you see CHHOH and then 1R group. Okay, so you can see HH, there is no CH3. Okay, so this one is wrong. So left with B, okay, so I will, which is our correct answer. Okay, I will draw for you the B. Okay, for B, you see here the carbon. The carbon has 1H, OH, CH3, and then this is going to be the R group. So they match. Okay, so therefore you will get the answer as B. Okay, now I will move on. Okay, I will go a bit fast over here. Okay, but if you have any questions, okay, you can let me know. Yeah. Now, when compound X is heated under reflux, okay, with sodium hydroxide solution, so this is going to be hydrolysis, okay, reaction. So, what kind of a hydrolysis reaction? I saw that octanoate and ethanol. So it means I'm talking about ester lah. Yeah, I know it's going to be ester. So I'm dealing with ester, and I can see all of them here. Okay, A, B, C, D are all ester. Okay, so if it is hydrolysis, I need to find out what are the bonds that will be broken. This bond, this bond. Okay, so I'm going to get ethanol. Okay, ethanol 2 carbon. Okay, the H will come beside O here, H. Okay, beside here. So just make sure that you have 2 carbon. 1 carbon, 2 carbon, possible. You see, 1, 2, 3, all this, not possible at all. Okay, you need 2 carbon alcohol only. Here, okay, 1, 2, possible. You have many here. Okay, not possible. So from here, I have eliminated B, I have eliminated D. So now left with, okay, the sodium octanoate. Octanoate means 8. Okay, octa. So it means that, okay, the carboxylic acid part, okay, that will change with the to salt must have 8 carbon. So I count 1, 2, 3, 4, 5, 6, 7, 8. Double confirm. 1, 2, 3, 4, 5, 6. Hexa. Cannot be octa. So therefore, the answer is going to be A. Okay, I will move on. 29. My favorite. Okay, so the moment you see this, okay, you will see, okay, this is going to be alcohol. Anything to do with alcohol, yeah. So you can see here, okay, this is carboxylic acid, no. Okay, and this is ester, no. Aldehyde, no. Automatically, I know, no need to look at other things. Automatically, I know it's going to be alcohol. Okay, this is the only thing that with alcohol, and of course, there is other things as well. Okay, maybe represented by this and so on, but I don't care. I know that this is going to be alcohol. Okay, and then they say that, okay, this is the empirical formula. Yeah, so this is, you just need to find out or guess, okay, what will be the best answer. Yeah, so the best answer, I think this one, A. Okay, quite simple to do. Yeah. Now, question number 30. Which pair of test result will prove a substance is going to be aldehyde? Now, if it is aldehyde, do remember, if I have carbonyl compound, okay, aldehyde and ketone, only aldehyde can give you positive reaction with Fairlink, okay, and toluene. Okay, so toluene's region, okay, they will give you the silver mirror. Okay, Fairlink will be the blue, will become the red precipitate. Okay, the brick red precipitate. So if you have this, okay, do remember aldehyde and ketone, they will react with 2,4-DNPH. Okay, so using this knowledge, we are going to identify how to prove X is aldehyde. Now, X reacts with toluene's region. Yes, correct. X reacts with alkaline aqueous iodine. This one, not really. Yeah, not really. Triiodomethane, okay, you need to look at what type of aldehyde. Only ethanol can react. Okay, the other aldehyde cannot react. Okay, so A will not be the answer. X is reduced by lithium aluminium hydride. Okay, reduced. So it means they are telling that they are going to be reduced to become primary alcohol. X reacts with hydrogen cyanide. Correct also, because we learned about ACN. Yeah, carbonyl compound can react with ACN. Okay, but okay, is this 100% correct for aldehyde only? Now, do remember, I need to prove. How about if it is carbonyl compound? Okay, what is another carbonyl compound which is going to be ketone? So if it is ketone, ketone can be reduced to with the lithium aluminium hydride as well. Okay, to give you secondary alcohol. And ketone can react with hydrogen cyanide. So you cannot say the test at B is going to prove that this is going to be aldehyde. They can also be ketone. Okay, so it's not going to be correct. X reacts with toluene region. Yes. X has no reaction with Fairlink's region. Doesn't make sense. Both of them must be positive. And X reacts with 2,4-DNPH region. Yeah, correct. Okay. X reacts with Fairlink's region. Yes, correct. Okay, ketone. Ketone, they will react, but they will not react with Fairlink's region. Okay. Therefore, you can prove that this is going to be aldehyde. Okay, that's why it's going to be, the answer is D. Okay, if there is a mistake, you probably would have selected boy, yeah, as the answer. Okay, so I have explained to you why. Now, I think the moment we start with question number 31 all the way to 40, I think it's actually quite simple. Yeah, if you're struggling with this kind of question, okay, then I think you need to improve on your concept. Yeah, so if you look over here, so they say that, okay, methanol can be produced industrially, okay, by reacting these two. Yeah, so this process can be carried out at this condition and so on. Okay, which of the statement is going to be correct? Now they're talking about increasing temperature. I know that this is going to be hot, this is going to be cold. Increase the temperature, yes, of course they will increase the rate of reaction, correct? Because more effective collision will occur, yeah, correct. Number one is correct. Lowering the temperature. Okay, when you lower temperature, I need to increase the temperature. So how do I increase the temperature? I go to the right, cold to hot. So it will reduce the rate of reaction. Of course, they will reduce the rate of reaction, low temperature. Okay, but increase the yield, yeah, because you are moving to the right. Okay, you are producing more methanol. Okay, so this is also correct. Increasing the pressure. So we talk about the gas. Okay, so you have 3, okay, 1 plus 2, and then 1. So if you increase the pressure, I need to decrease the pressure. How do I decrease the pressure? By forming, moving to the right, okay, to form less number of moles, yeah, or molecule. So when I do that, okay, increase pressure, of course, you are going to increase the rate. Okay, that is correct. Shift the equilibria to the right, which is also correct. Okay, so the answer is 1, 2, 3. Therefore, the answer is A. 32. Which of the following quantities is equal to Avogadro constant? Avogadro constant is for 1 mole, yeah? So the number of molecules, do remember nitrogen gas, if they say molecule, 24 dm cube at room temperature and pressure, that is 1 mole, okay? Molecules, okay? So this is going to be 1 mole. So automatically it will represent Avogadro constant. Now, number of ions, this one is very important. If they say number of molecules is different, but they say number of ions, how many ions that you have? You have Na plus, you have Cl minus, you have 2 times by 2. Okay, if you have 0.5 mole, so that 0.5 mole must times by 2. So we are talking about 1 mole again. Okay, 1 mole of ions. 1 mole of ion, 1 mole is Avogadro constant. Okay, therefore this is also correct. Number of atoms in 40 grams of argon gas. Don't go and put argon gas is like this, yeah, I'll knock your head. Yeah, so this one very, very important. Okay, your group 18, yeah, your noble gases must be always a monoatomic. Okay, must be always monoatomic. So if you make mistake over here, okay, please take note. Okay, it must be a single atom, AR. And if you have 40 grams, how many moles? 40 divided by 40. So 1 mole. Yeah. So this is already 1 mole. Number of atoms in this, okay, of course, is going to be Avogadro constant as well. Okay. So this one is going to be A. Okay. You can see it's quite easy, okay, to understand this. Now, which type of intermolecular forces exist in this? Okay. Now, this is polymer. Okay. They are going to continue. They will be like, for example, if I have this, okay, if I select this and then I copy this, they might have, if I paste the image here, it means they will have interaction from here to here also. Okay. You need to imagine in that way. And I know Cn is already has delta positive, delta negative. This is delta negative, delta positive. Delta negative and delta positive, they will interact because polar. Okay, so if it is polar, definitely it's going to be permanent dipole interaction. All molecules will have van der Waals forces. Okay, but what is ion dipole interaction? Yeah, ion dipole is going to be something like this: Na plus. And I have HOH, this one delta positive, delta negative. Okay, if I have delta negative here, H. Okay, so if I have like that, okay, they are going to be forming. Okay, if I have this Cl, then they will be attracted, they will be separated. This is what we call as ion dipole. I don't have any ion over here. There is no free moving ions here. Okay, there's no ion. Okay, therefore, okay, this one will not be correct. Okay, so this is going to be C. This can be C. Now we know, okay, carbonates, okay, when they thermally decompose, okay, they will give you oxide, okay, and then they will give you carbon dioxide. But we know that as you go down the group, okay, the thermal decomposition is going to be difficult to happen. You need more temperature to decompose them. Difficult to decompose. So we know here there are some element here, which is strontium, barium, which is going to be at the bottom of the group, okay, which is going to be difficult to decompose. So if let's say I'm going to heat up, okay, I'm assuming the one that is at the top, they are completely decomposed. Okay, for example, okay, this compound. Okay, maybe water given out, magnesium carbonate also, okay, they decompose to give you magnesium oxide, and then carbon dioxide is given off. But this one do not decompose, so they stay as SrCO3. They stay, okay, they don't decompose. Now, here you can see calcium, okay, this one, they decompose to give you carbon dioxide, so you have calcium oxide. Okay. But barium carbonate, they don't decompose because difficult to decompose. So you keep it that way. Okay. And then carbon dioxide is given out. Carbon dioxide is given out also here. Here, magnesium carbonate, okay, they decompose, okay, to give you carbon dioxide. Calcium carbonate also they decompose to give you calcium oxide. So you are going to get calcium oxide and magnesium oxide. Okay, these are the solids that are remaining. So now I'm going to add hydrochloric acid. So Ella was correct. Yeah, when you are adding hydrochloric acid to oxide, you are going to get salt and water. Water is not counted as effervescence. Yeah, effervescence must be gas, right? So if I'm adding with magnesium oxide, there shouldn't be any effervescence. Okay, so no effervescence is seen. Okay, if I add A over here, no effervescence should be seen as well. Okay, so this one, no effervescence. Okay, but how about number one? No effervescence here, but there is effervescence here. Okay, strontium carbonate plus acid, they will give you strontium, the salt, carbon dioxide, and the water. Okay, so there is effervescence here. Here, barium carbonate, there is also effervescence when you react with acid. So therefore, the answer is going to be 1 and 2. I remove the 3. This is the better explanation for that. Is that clear, Jonathan? 5. Which statement below are correct about this hydrogen halide? HCl, HBr, and HI. Now, this one something to do with reactivity also. Yeah. You see for HCl, okay, how do you form HCl? Hydrogen with Cl2, hydrogen with Br2, and then hydrogen with HI. Which one is going to be more reactive? This one we also learned. Okay, reactivity for the metal, it's going to be ability to lose electron. For non-metals, okay, it's going to be ability to attract electron. And you know that Cl2 is going to be smaller, okay, compared to I2. So Cl2 is going to be more reactive, okay, compared to I2. Okay, so the reaction between H2 and Cl2 is going to be more vigorous, okay, and compared to this one, if you remember, they will form equilibrium. Yeah, so it's not so reactive. So here, when they say formation of HCl from its element is the most vigorous reaction, the answer is correct. Okay, this is the first thing that you notice over there. So number 2 is always is correct. Now HI is the most easily decomposed on heating. The answer is correct also because HI, I is going to have the bond length is going to be greater. Okay, the longer bond length. So it's going to be easier to be broken, okay, compared to HCl. Okay, so this one is going to be most easily decomposed, correct also. And then they have permanent dipole in their covalent structure. Of course, this is delta positive, delta negative. Okay, so this is going to be permanent dipole. Okay, so this is going to be A. 36. Okay, which statement about free radical monochloro substitution in ethane are correct? Now, what is monochloro? Yeah, monochloro is going to be only one hydrogen is going to be substituted, okay, by the chlorine. So it means now if it is ethane, yeah, I'll just draw for you. If this is going to be ethane, so only one of the hydrogen is substituted by the Cl. Now, students will get confused. Maybe is it typo error or what? Butane is present in small quantities in the product mixture. This one, remember last time, okay? I told you if you have Cl2, they will have 2 Cl dot, okay? And then this is the initiation. Propagation, what will be the propagation? C2H6, okay, plus with the Cl free radical, I am going to get C2H5 dot, and then HCl, and then this C2H5 dot, okay, plus Cl2, and I will get C2H5Cl plus Cl free radical, and it will continue, right? Okay, now what will happen here, okay, if you have the termination step, if I take this, okay, C2H5 join with C2H5, what will happen? I will get C2, if I draw, will be much more better, sorry. I will get C2H5, and then with another C2H5. So this is going to be butane. This is the product of termination. Okay, you will get a product of termination. So it means it's not going to be a lot. Okay, it's not under propagation. Therefore, okay, butane is present is correct. The main bulk of chloroethane comes from the propagation step. Yes, of course. Okay, it's coming from the propagation step. And then the reaction proceeds quickly in dark room. No, it must have presence of sunlight. Okay, so it cannot proceed quickly in dark room. So must be answer is going to be 1 and 2. So therefore, it must be B. Now, for question number 37, okay, this is there was a mistake. Okay, but I will just discuss a bit over here. Okay, so this one is bonus. Okay, there is no answer. Okay, but anyway, I'll just discuss. You see here, okay, they give you this. Okay, so this one, let's identify. This is going to be, is it going to be primary, secondary, or tertiary? Okay, if I just look at it, it's going to be CH2, okay, and then Cl, and then there is carbon. So this is the entire thing over here. Okay, it's going to be 1R group. Yeah. So it means that, okay, this is going to be a primary halogenal alkane. Okay, if I look over here, this is going to be a tertiary halogenal alkane, CHCl, okay, 2R groups. Okay, this is secondary. Okay, you should be able to identify by now. Okay, once I have this, okay, they say that, okay, the primary over here, they will react with NaOH by SN1 mechanism. Wrong. It must be SN2 mechanism. Okay, so cannot. Okay, now the tertiary chloroalkane reacts more quickly than the others because the carbon atom is bonded to Cl atom is more positive in this molecule. The answer is wrong. Okay, why? Because you see, if you have carbon atom and then you have one R group, another R group, another R group, you have Cl. Yeah. So I know that tertiary they will form carbocation. So of course, okay, they will form this positive over there. And I know the R group, okay, they are electron donating group. Yeah. So when they donate electron, the electron will come here. Okay. So remember, I told you the carbon, okay, if they are sad, okay, if you have more people, okay, then they can share the sadness to a lot of people. Okay. So they will become more stable. So what happens is this positive charge, okay, we call it as positive inductive effect. The positive charge will be shared equally among all the carbon that is bonded over here. It means that positive is going to be reduced. Okay, it will become less positive. Okay, less positive. So if you say it will react quickly because it's more positive, the answer is wrong. Okay? That's why that is wrong. Now, the Cl atom in the 3 chloroalkanes are attacked by OH minus. That is also wrong because you do not go, the OH minus do not go and attack the Cl. They will go and attack the carbon. Okay, they will attack the carbon. So therefore, okay, that is also wrong. So no answer. Okay, that's why it's bonus. Okay, now 38. Which of the following, okay, are the correct statement, okay, about electronegativity of elements? Okay, do remember what is the meaning of electronegativity? The ability to attract electron in a covalent compound. Okay, so it means you are attracting bonding pair of electrons. You are not actually getting the electron from somewhere else. That is called electron affinity. Okay, that is in A2. So this one is within the bond. Okay, but we can roughly use your periodic table. Okay, and then the size. Okay, it becomes smaller and smaller. Okay, when you go to the right. Okay, and we can predict, yeah, the electronegativity from there. In period 3, electronegativity increases from sodium to chlorine. The answer is yes. Okay, because you can see if sodium here, chlorine is here. Okay, so of course the attraction is going to be greater. That's why, okay, that's why it's smaller. Okay, so they can attract the electron easier to themselves. Okay, so electronegativity increases, correct. In group 2, okay, so if barium to beryllium, I know beryllium is at the top, barium is here. I know this is going to be, it will become bigger and then bigger, okay. And what happens, okay, is going to be, if I'm talking about electronegativity, this one will be able to attract electron easily compared to this, okay, not so good, okay. So if they are telling from barium to beryllium, so from here to here. So of course they tell electronegativity is going to increase, yeah, because better, yeah. So this one is correct. In group 17, yeah, so same, yeah, fluorine to iodine. Okay, so fluorine is here, iodine is at the bottom. So this is bigger, this is smaller. Okay, and then it's much more easier to attract here, not so good over here. So they are telling from fluorine to iodine. Okay, so you can see electronegativity decreases. Okay, but they put increases wrong. Okay, therefore the answer is 1 and 2 only. Which statement, okay, about formation of carboxylic acid, okay, they are correct. Now this one, you need to understand about how you get carboxylic acid. Yeah, and one of the important way to get carboxylic acid is by using nitrile. Yeah, so nitrile, if you have nitrile, okay, they say that it can be produced by hydrolysis of nitrile. Yeah, so is that correct? Okay, the hydrolysis that they meant is by using HCl under aqueous condition, means the plus H2O. Okay, you go and find out about this. Okay, when these two, okay, they are going to give you RCOOH. Okay, and then they are going to get NH4Cl. This is what is going to happen. Okay, and I don't think so it's balanced. Okay, you balance yourself. Okay, but this one is important. Okay, so number 1 is correct. A carboxylic acid can be produced by reacting primary alcohol with acidified potassium manganate. So it means you're oxidizing it. Okay, primary alcohol, if you oxidize, you get aldehyde. Further oxidation, you will get carboxylic acid. So correct. A carboxylic acid can be produced, okay, by reduction of ketone. Ketone, you will get secondary alcohol only. Yeah, so this is wrong. Okay, so the answer is 1 and 2. Boy. 40. Okay, the following are examples of carbonyl compound. And they say that, okay, you use 2,4-DNPH and Tolan region. Okay, identify first. Okay, OCH3, CH2, so this is ketone part. Carbon, this is also ketone. Hydrogen, so both of them are aldehyde, this part, and also aldehyde, this part as well. Identify first. Carbon, ketone. Oxygen, hydrogen, so this is aldehyde. You identify that first. Okay. Now, which compound gives you positive results with 2,4-DNPH? All of them. Yeah, ketone, aldehyde, ketone, aldehyde. Okay, all carbonyl compounds will give you positive results. Okay, but okay, does not form silver mirror upon addition of Tolan region. Now, silver mirror, it means if you have aldehyde, then they will give you silver mirror. Okay, so it means they are talking about ketone. Yeah, so the one that cannot have aldehyde. If you have aldehyde here, they will give you silver mirror. They will give you silver mirror. They will give you silver mirror. Ketone, no silver mirror. So therefore, only one. Therefore, the answer is D. Okay, so done. Okay, all the way to question number 40. Okay.